Building machine learning isn't the hard part. Scaling it is. And most US companies don't get stuck because the team isn't smart. They get stuck because the team isn't structured. They hire great people, then they scatter responsibilities, overload the first hire, and quietly hope one unicorn can handle research, modeling, data pipelines, deployment, monitoring, and stakeholder updates. That's not a strategy, that's a burnout plan. So what actually works? First, start with the goal, not the org chart. If you don't know what the business needs from ML, you'll build a team that looks impressive and ships nothing. Here's what bad usually looks like. One person owns everything. Data science sits separate from engineering, so models never get into production. Teams overinvest in experimentation and underinvest in ML ops. And roles shift week to week, which slowly breaks your best people. Then leadership starts asking the wrong question. Is ML worth it? The truth is, the structure was never set up to succeed. Here's what good looks like. Clear ownership across the entire ML lifecycle. A team designed for repeatable delivery, not heroics. Data, ML, and product moving in the same rhythm. Reporting lines that reduce friction, and hiring in waves that match maturity, not hype. That's the whole game. Let's talk roles, not job titles, responsibilities. A scalable ML team covers the full journey: data, model, deployment, monitoring. And you need coverage across that stack. At the leadership level, 2 roles change everything. 1. Head of ML or Director of ML Engineering. This person owns strategy, architecture, and delivery. Not just prototypes, delivery. 2. Product Manager for ML. This is the most underrated hire because they connect business needs to ML capabilities. They define success metrics, and they stop the team from building cool things nobody uses. Then the execution layer. ML engineers turn models into production-grade systems. They live between modeling, software engineering, and ML ops. Data scientists or applied scientists explore, experiment, validate feasibility. They should be partnered tightly with ML engineering, not sitting in a separate universe. Data engineers build the foundation, reliable pipelines, validated data, scalable systems. And if you underinvest here, your ML roadmap becomes fiction. And then there's ML ops, or ML platform engineers. They own deployment, tooling, CI/CD, monitoring, model registry, governance. This becomes essential once you have more than a few models in production. Here's the key point. In early-stage teams, people can cover multiple functions. But when one person covers the entire stack, reliability drops, and delivery slows. As soon as ML becomes a core product capability, specialization isn't a luxury, it's mandatory. Now, structure. There isn't one perfect org chart, but there are 3 models that actually work. Model 1. Centralized ML Center of Excellence, usually under the CTO, CIO, or head of data. Best when you have fewer than 3 real ML use cases. Pros: shared standards, shared infrastructure. Governance is easier. Cons: it can turn into a service bureau. Slow feedback, weak product connection. If you're early, it's still often the right call. Model 2. Hub and spoke with an ML platform team. This is the model we see work best as companies grow. Hub, platform and ML ops team. Spokes, ML engineers and data scientists embedded in product teams. Pros: speed plus consistency. Shared infra without slowing product teams. Clear ownership for reliability. Cons: it requires leadership alignment. And if the platform team stays too small, everything bottlenecks. This is the most common shape for Series B to D companies in the US. Model 3. Fully product-embedded ML teams. ML engineers report into product or business units. Pros: deep alignment, fast iteration, clear accountability. Cons: duplicated infrastructure, harder standards, messy governance. This only works when you already have a mature platform. Here's a simple rule of thumb that holds up. Under 3 use cases: centralized, 3 to 10, hub and spoke, 10 plus, across multiple teams, product embedded. That progression is natural and healthy. Next, reporting lines. People love debating whether ML should sit under engineering, data, or product. But the truth is, none of those choices matter if ownership is unclear. Here's the pattern that scales. Product ML teams own model behavior and business outcomes. Platform teams own tooling, deployment, monitoring, and guardrails. Data engineering owns the data foundation. That separation prevents duplicated work, and it prevents model chaos. Now, benchmarks. Because leaders always ask, how many people do we need? Ratios vary, but here are realistic US benchmarks. Early stage, 1 data engineer for every 2 to 3 ML or DS roles. Growth stage, closer to 1 to 1 or 1 to 2, depending on data complexity. Late stage, it's less about ratios and more about clear interfaces between teams. ML is data heavy. As complexity rises, underinvesting in data engineering becomes the biggest bottleneck. When do you hire your first ML ops or platform engineer? Most companies do it too late. If you have more than 5 production models, it's already late. If deployment takes weeks instead of days, it's late. If ML engineers spend more time writing infrastructure than writing models, it's late. If monitoring gaps keep causing regressions, it's late. In practice, the need often shows up after the second ML engineer joins or after the third production use case. Here's the takeaway. Machine learning doesn't fail because teams lack talent. It fails because companies don't build the structure talent needs to succeed. Treat ML like product engineering. Assign ownership across the lifecycle. Choose the org model that matches your maturity, and hire in waves that match your roadmap, not the hype cycle. You don't need the perfect org chart. You need one that makes delivery predictable. That's how teams go from hiring ML to actually build with it.